Hello and welcome to the 8.3 notes. I know this says 6.2 notes, but we're going to have to go ahead and change that real quick to 8.3. That's what it is in our book. So, but this is, day one of differential equations. And so typically what we've seen is we've seen these derivatives and second derivatives that are functions of x, okay? So, but what we call these differential equations is because they're not necessarily functions, they're equations. So we're going to use the strategy called separation of variables, okay? And the only thing I'm going to say about separation of variables is that we want to get the x's and y's on opposite sides of the equal sign. Okay, opposite sides of the equal sign. Okay, and so and let's kind of show you what's going on here with this differential equation. We want to solve for y as a function of x. Now, what we notice here is that this differential equation, dy dx is equal to 2x over y. This is not a function, okay? This derivative is an equation because it has two different variables in it, okay? So what I want to do is I'm going to rewrite it over here first and say that dy dx is equal to 2x over y. Now, the one thing I'm going to do is I'm going to get all my x's on one side and all the y's on the other. So I want to first take this y value, and I'm going to multiply both sides by y, okay? So that I get this. I get y times dy dx is equal to 2x, okay? And then I want to move my dx over. Okay, I want to move my differential over, so I'm kind of essentially multiplying by dx, but I'm really just moving it over. And so we end up getting this, all right? We end up getting this next statement that says y dy is equal to 2x dx, okay? And now, at this point, I have separated my variables, okay? Now, the interesting thing now is that we want to get y by itself, and we want to get rid of the dy, and we want to get rid of the dx. And the method that we want to do for that is we want to integrate both sides, okay? And so what happens is that I can take the antiderivative of this side, and I can take the antiderivative of this side. And as a result, I get y squared over 2 is equal to 2x squared over 2 plus c, okay? Now, when we do this, okay, when I take the antiderivative, I don't have any bounds, so I have to add the plus c. I don't add one over on this side, okay? I only put the c over on this side, okay? And we'll kind of explore why we do that, but, when we add that constant, it's just any normal random constant, okay? If I add one over here, I'm going to have to move it over here anyway. So it's kind of just one of those things where, we just need to put it on the right side. Okay, so the c only goes on this side. So what I want to do now is I want to now solve this equation for y. All right, so let me do a little simplification here first on this next step, and let me say that we get y squared over 2 is equal to, the 2's divide out here, and we just get x squared plus c. All right, so now what we do, I'm going to go ahead and multiply both sides over here by 2. Okay, and when I do this, all right, this is where it gets a little tricky, is that I'm just going to get y squared is equal to 2 times x squared plus c. Okay? Now, what you'll notice here is that I multiplied just the x squared by 2. I didn't multiply the c by 2 because I don't need to, okay? C is an arbitrary constant, okay? If I multiply it by 2, it has no difference than me not multiplying it by 2. This is kind of weird, but this is just kind of how it goes. So I'm not going to do anything here. I'm just going to multiply this x squared by 2, okay? Then what I'm going to do is I'm going to take the square root of both sides and get y by itself. Okay, so if I take the square root of both sides, then I end up getting this. I end up getting that y is equal to plus or minus the square root of 2x squared plus c. Okay, and this, my friends, is what we call the general solution. Okay, this is our general solution. And so what this is this is our function y, okay? And what I want you to notice here is that we have two different options here, okay? We have a value, we could have the positive square root of all this, or we could have the negative square root of all this. But the fact is that we get this general solution, and in this next part, we're going to use that general solution to find our particular solution where we have the initial condition of y of 1 is equal to negative 3, okay? So what I want to do is take our general solution, which was y is equal to plus or minus the square root of 2x squared plus c. Okay, we have that initial condition of y of 1 is equal to negative 3, okay? And so what I want you to notice here is that in this equation, okay, this means that x is equal to 1 and y is equal to negative 3. Okay, now on this equation, okay, we have this plus or minus symbol, okay? And what we know here is that the y value is negative, okay? And I'm going to note that here. This value is negative. Okay, value is negative. So because this y value is negative, that means that we choose, okay, the y value is negative, so I want to write that we choose the negative square root. Okay? And so, I'm going to come over here, and because my y value here is negative, I'm going to choose the negative square root. So once I do that, I get y is equal to negative square root of 2x squared plus c. Okay? And now I'm going to plug in negative 3 in for y, and I'm going to plug in 1 in for x, and that's going to allow me to solve for c. Okay? So if I plug in, let me do that. Let me plug in negative 3 for y. So negative 3 is equal to negative square root of 2 times 1 squared plus c. Okay? And then I'm going to go ahead and divide by negative 1 on both sides. And so we end up getting this statement here that says 3 is equal to the square root of, and then 2 times 1 squared is just going to give me 2 plus c. All right, we have this equation here that we can solve, and we can square both sides. And we end up getting that 9 is equal to 2 plus c. And so if I subtract 2 from both sides, then we get that c is equal to 7. Okay? So now, according to our initial condition here, all right, I'm going to write our particular solution. Okay, particular solution, which is y is equal to negative square root of 2x squared plus 7, okay? And so that's our particular solution based off of this initial condition. Now, if this initial condition was different, okay, if our y value was positive, then we would choose the positive square root, okay? So it is really important. There is some trick to this. It's not as straightforward as the other ones where you would just, go ahead and just plug in your x and y value and solve for c, okay? So we've been doing this for a while, but the fact is that these initial conditions allow us to determine which part of the equation we're going to use, okay? And this kind of goes back into that what we did in slope fields, how I said that if if a certain initial condition was at one point on the graph, then the graph would look totally different than if the initial condition was on another part of the graph. So this is what I mean by that. So let's go ahead and let's take a look at example 2. Okay, and what we want to do is we want to solve for y as a function of x, all right? So they give us this differential equation. They gives us this y prime is equal to x squared times the square root of y. An initial condition of y of 3 is equal to 4. So what I want to do is I'm going to first rewrite this as dy dx is equal to x squared times the square root of y, okay? And I'm going to go ahead and separate my variables. I'm going to move my dx to the right side and then divide by the square root of y. So let me do that real quick, square root of y. And dividing by the square root of y, guys, is the same as multiplying by 1 over the square root of y. Okay, and then I'm going to go ahead and just multiply, move my dx over, and move my dx over. Okay, so this part goes away here and here. These go away here and here. So I end up getting 1 over the square root of y dy is equal to x squared dx, okay? And now what I want to do is I want to integrate both sides, okay? So I separate my variables and I take the antiderivative of both sides. But the problem is that right here, guys, I don't have a rule for this. I have to rewrite this just a little bit, okay? So I'm going to rewrite this as the integral of y to the negative 1/2 power dy. And this is equal to the integral of x squared dx, okay? So now we can take our antiderivative of both sides. And so I'm going to end up getting y to the positive 1/2. And then instead of dividing by 1/2, I'm going to multiply by 2, okay? And this is equal to x cubed over 3 plus c, okay? So I'm doing the plus c on the right side here. I'm not doing it on the left side, okay? And then I'm going to go ahead and get my y by itself, and I'm going to divide both sides by 2, okay? But this I'm going to multiply by 1 over 2, all right? So the 2's divide out, and we're going to end up getting y to the 1/2 is equal to x cubed over 6, and then plus c, okay? So really what I have here, guys, is I have, the square root of y is equal to x cubed over 6, and then plus c, okay? And in order to solve this, I'm going to go ahead and square both sides, okay, and I got to square the whole quantity. And so I end up getting this. Y is equal to the quantity x cubed over 6 plus c quantity squared, okay? Now, once I've isolated y and I have y is equal to something else, I'm going to call this my general solution, okay? And on that general solution, now what I want to do is I want to plug in my initial condition. Okay, so now I'm going to use the point, x is equal to 3, y is equal to 4. Now, the nice thing about this one is that, I don't have any choice as to what I'm going to do here, all right? It's simply just I'm going to plug this in and evaluate it and see what we get. So, let's go ahead and do that. I'm going to plug this in up here. So we've got y is equal to 4, and that's equal to the quantity 3 cubed divided by 6 plus c quantity squared, okay? Now I'm going to evaluate this a little bit and, see what we get. And that's going to give me, we get 4 is equal to the quantity, and this is 27/6 plus c, and it's squared. Okay, I'm going to take the square root of both sides to solve for c. So I end up getting 2 is equal to 27/6 plus c. Okay, and I'm going to get a common denominator. This is 12/6 is equal to 27/6 plus c. If I subtract 27/6 from both sides, then that's going to end up giving me that c is equal to negative 15/6. And so then C is equal to negative 5/2, okay? And so we've got this value here, and so I want to plug this back into my, my general solution. So I'm going to end up getting that y is equal to the quantity x cubed over 6 minus 5/2 quantity squared. And this is my particular solution, okay? Particular solution. All right. So this is a procedure. It is kind of an arduous procedure, but it's not too terrible. But what I want to do is go ahead and stop this video, and then we will continue on with another one. So please make sure that you're practicing this and that you're watching this and that you might need to rewatch this kind of stuff. And it's not too bad once you get the hang of it, but it's kind of tricky at the moment. So bear with me, and we'll see you soon. Thanks. Bye.